Circular motion summary. Angle. Angle is a measure of rotation or angular displacement. The common unit of angle is degree. SI unit of angle is radian. And one complete rotation is equal to 360 degree or 2 pi radian, or you can write 6.28 radian approximately if we convert pi into the decimal fraction 3.14. Here we have the concept of radian. Angle in radian is equal to arc length over radius. Take a look at the picture there. You can see the arc length L, radius R, and the angle theta marked, and theta is equal to L over R. And down there we have the conversion equation. 180 degree is equals to pi radian. You may use this conversion equation to convert from degrees to radian or radian to degree. Angle in radian is equal to arc length over radius. You have already learned about that. Theta is equal to L upon R. And 1 radian, you can work out the value and you will find it 57.296 degrees. Check whether it is right or not. And then 1 degree, if you convert that into radian, it's approximately equal to 1.745 times 10 to the power minus 2 radian. Now we have the basic concept of uniform circular motion. When we talk about uniform circular motion, it means that the tangential speed should remain constant, but of course tangential velocity will not be constant because the direction of the motion changes continuously. That means the tangential velocity changes continuously. Therefore, the body is continuously accelerating. This acceleration is called centripetal acceleration, and it is constant in magnitude, but always directed toward the center of the circle. This equation is about angular speed. Angular speed is equal to angular displacement over time, or you can say omega, that is the letter representing angular speed. Omega is equal to theta over t. Here omega will be in radians per second. Then we have tangential speed. In case of uniform circular motion, tangential speed is equal to arc length upon time. In non-uniform circular motion, you have to change it because you need to ensure that the arc length is infinitesimally small. So you should write V is equals to dl by dt. But in uniform circular motion, you may write V is equals to L over t. Then, how tangential speed and angular speed are connected? Now, we can get the equation. Tangential speed is equal to radius times angular speed, or you can write V is equals to R omega. Now, here we have the concept of frequency and the period of revolution. Now, frequency means how many turns the body orbits around in 1 second. So, number of complete cycles the body covers. Now, frequency is the reciprocal of period of revolution, or you can just write F is equals to 1 over t. And we have a couple of other equations connecting angular speed and frequency and time period. Angular speed can be written as 2 pi over time period, 2 pi by t, or you can write it as 2 pi f. So, very important relationships. Now we have seen this relationship already. The first one, V is equals to R omega, tangential speed is equal to the product of the radius and the angular speed. And we have centripetal acceleration. Centripetal acceleration is equal to the square of tangential speed over the radius, or you can write ACP, that's equals to V square over R, or you may write it as R omega square. Now, then centripetal force, you can apply the Newton's second law, F is equal to ma, and you will get FCP is equal to m times ACP. So you get the expression FCP is equal to m times V square over R, or m times R omega square. And the most important thing that you need to remember about centripetal force is that centripetal force is an unbalanced force. What does it mean by that? It means that centripetal force actually causes the body to accelerate, makes the body accelerate. A balanced force will not make the body accelerate, but an unbalanced force can make the body accelerate. So centripetal force actually accelerates the body towards the center. Also, you must remember the centripetal force can never perform any work because the displacement will be always perpendicular to the force. So the work done will be zero in that case. So there won't be any work done when a body moves along a circular path. Now, here we will see the circular motion in vertical plane. Suppose a body moves in a vertical plane, like if you have a body attached to a string and whirl it around your head, you will see that the body moves in a circular path, and you will feel the tension on your hand. The string will be exerting a tension. So the first equation is the tension on the string. You can see that in the picture. It is marked as T. Tension is given by mv square over r plus mg cos theta. And we can see that in this case the motion is not uniform. The speed will be maximum at the bottom and minimum at the top. Now we will see the minimum speed required to keep the body moving in a circular path. At the top point B, the minimum speed to keep the body moving in a circle is given by V is equals to square root Rg. Similarly, at the bottom, the minimum speed required to keep the body moving in the circular path is given by V is equal to square root of 5 Rg. Now we will see some of the very common phenomena in which centripetal force plays an important role. First, we will start about the motion of the celestial bodies like planets or satellites. Planets are revolving around the sun. Satellites are revolving around the planet. In these cases, if we assume that they are moving in nearly circular orbit, there must be some centripetal force. So in case of celestial motion, centripetal force is provided by the gravitational force. For example, the Earth moves around the Sun because of the centripetal force because of the gravitational force exerted by the Sun on the Earth acts as the centripetal force to keep the Earth in its orbit. Similarly, if you consider the motion of electrons in atoms, as described by the classical physics, electrons are revolving around the nucleus. In this case, the centripetal force is provided by the electrostatic force of attraction between the nucleus and the electrons. So, centripetal force is equal to the electrostatic force. Now, here we have taken two examples. One is the bagging of an airplane. Suppose an airplane wants to take a turn, it has to tilt its wings. And when it tilts its wings, the horizontal component of the lift will provide the centripetal force. And of course, the vertical component of the lift will support the weight of the plane. And a similar case, when we take the example of curved roads with properly banked, you can see that the centripetal force is provided by the horizontal component of the reaction force, and the vertical component of the reaction force balances the weight of the vehicle. Now, in both these cases, the optimum safe speed is obtained by the relationship V is equal to square root of RD tan theta. So these are the major points that we have gone through in this chapter. I think I have covered almost everything in this chapter, but still you may go through the syllabus and see if you want to add more to it and to work out more examples on this.